Of exponents. We're going to do this as part 1. We're going to go into, this is the stuff that has been taught in the past in junior high through Algebra 1. We're going to spend a little bit of time on these properties, which is some of your more basic ones. And there are 4 properties I think we're covering today. So the first property we are going to look at is the product property. And so the example of this is if I have x to the 4th times y to the 3rd times x to the 7th. If I want to combine my variables, I am multiplying all of these. So what that means is I have x times x times x times x, and y times y times y, and x times x times x times x times x times x times x. So how many x's am I multiplying together? 11. Does anybody remember the shortcut for figuring that out without having to go through that process? So we would add those two exponents together. So the shortcut would have been x to the 4 plus 7. And y didn't have anybody like it, so that's how you could have shortcutted it versus doing this whole process. So when you're multiplying the bases, you can add the exponents if the bases are alike. What is anything to the 0 power?
0.
Nope.
1.
1. That means there are 0 x's. What is the coefficient in front of here that's not written? So if you have 0 x's and 1 is what it's being multiplied to, the answer is going to be 1. So I could say
Answer 0.
the answer will be 1.
What is tangent x?
Something that you'll get to, you should have covered in geometry, and then you will cover more in pre-cal.
We're doing that right now in geometry.
What if I don't do pre-cal? What if I
Then you don't have to do that again.
Yeah.
Okay. So power property. So let's say I have 3x y to the 5th all raised to the 4th power. I'm going to write it out the way it should be expanded. There is a shortcut. See if you can figure out the shortcut. So if I was just to write it out, that means I have 4 of these being multiplied. And so, thinking back to the property that I had just before, if I'm multiplying bases, I add exponents. Well, I have 4 3s, so 3 to the 4th. I have 4 x's, so x to the 4th. And I have 20 y's because I have y to the 5th 4 times. So, what's a shortcut of doing that? Distribute that 4 to each one, what operation am I going to do when I distribute? We are going to multiply. So the shortcut would have looked something like 3 to the 4th, because 4 times 1 is 4. X to the 4th, because 4 times 1 is 4. Y to the 5 times 4. And that's how you could get in there. But it's not best to write 3 to the 4th as 3 to the 4th. You want to write anything that's numeric as its number. So use your calculator. This is the only part you might want a calculator. 3 to the 4th is what number? It's going to be a big number. It is 81 squared. Or no, it's 81. Excuse me. That's your final answer.
So you don't have to put like a times sign or whatever?
No, because they're being multiplied. And when you have variables side by side with variables, it's understood multiplication. That didn't look right, so. Okay, the negative property. So, if I have something like 2x to the negative third, that means whatever's being raised to the negative power changes from numerator to denominator. So that would be 2 divided by x cubed. Anything that's got a negative power automatically changes from numerator to denominator, or denominator to numerator. And I'm about to show you the other way here in a second. So if I had x to the 5th, y to the 4th, divided by z to the negative 10th. The only thing that moves places is going to be that z.
On the top, are we supposed to change it from negative to positive?
Yes. And so you'd end up with x to the 5th, y to the 4th, z to the 10th. Sorry, I almost forgot the quotient property. So if I have 2x to the 1st, y to the 10th, divided by 3x to the 4th, y to the 7th. I'm again going to expand it out there as a shortcut.
Wow.
When you divide, don't you subtract exponents?
When you divide, you do subtract the exponents. You're correct. And so when I cancel, we're left with 3 y's in the numerator, 3 x's in the denominator, and the 2/3. So 2y cubed, 3x cubed. And so you would subtract them to cancel. Now, how do I know which side to end up on? This is where you need to read directions. The directions will either say only positive exponents, or it'll say something to the effect that you can have negative exponents. if it says only positive exponents, you're going to want to subtract and put them on the side that there are more. So numerator, denominator. That's the way our instructions today are going to be.
Does y always go on top?
No.
It doesn't matter.
It matters based upon which of these two numbers is bigger.
On the y?
Yeah, on the y. So the y has a 10 bigger than the 7, so the y would move to the numerator. On the x, the exponent is bigger in the denominator. So it's using this in the denominator. These rules are not going to be given to you as standalone rules. They are going to be given to you where they are in a process of a problem. And so let's look at one. If you have a cubed, b to the negative third, risen to the fourth power, divided by a to the first times 2a cubed b squared. So what do you think you might do first?
Multiply the top by the 4 exponents.
Distribute that 4 exponent. So clear your parentheses first if you can. So that would be a to the 12th, because 4 times 3 is 12. B to the negative 12th. A to the first times 2a cubed b squared. Okay, what do you think you might do next? I typically get my numerator and denominator cleaned up to where they have only one of each variable. So, in this case, that means combining my a's and my denominator. So I have a to the 12th in the numerator, b to the negative 12th in the numerator, divided by a to the 4th, b to the 2nd. There are two different possibilities at this point. We have a negative exponent. What does a negative exponent tell us to do?
Wait, where did the 2 go?
Oh, I forgot to write it. It's supposed to be in front. Thank you for catching that.
Wait, how did you get to the... Do you distribute the 4 on the top to the 1 on the bottom?
No. 1 plus 3 is
4?
4. That's where this 4 came from. So I combined my exponents because multiplication means I'm adding exponents.
So is the b squared separate from the 2a 4?
No, it's multiplied.
Okay.
And so in my numerator, I now have a to the 12th. In my denominator, I have the 2 times a to the 4th times b to the 2nd times b to the positive 12th. Combining my b's in my denominator. Some of you are going to be skipping some of these steps. I'm just writing them all out so you see where every single step comes from. B to the what power? Now, what's the only thing left to combine? What's the only thing I have two variables on? They're the same. Yeah. We have two a's raised to a power. What property is going to let me simplify those? The quotient. And so the quotient says that I am going to subtract and put it where the exponent is the largest. Which means I have a to the 10th over b to the 2b to the 14th. Yes, it would be 8. I was thinking I was subtracting 2.
Alright.
Okay, let's do one more. And then I'll let you start on your homework.
Is it on Pearson?
No.
That's all.
Buzzy.
Thank you.
Yeah.
Okay, how would I simplify this down?
Distribute the 0 to make that one.
So if I distribute the 0, that's going to go to everybody. Anything in that parenthesis is going to become a 1. Because anything raised to the 0 power is 1. So my numerator is now 1. Is there anything else to combine?
No.
I'm done.